Hello wonderful person, this is Anton, and today we're going to be discussing some really bizarre discoveries when it comes to unusual planets. And specifically we're going to be discussing a world that shouldn't really exist the way it does. And though we've talked about various unusual exoplanets before, this recent study from March of 2026 revealed to us a completely new type of molten planets or lava worlds that helps us understand how these planets seem to form and what they seem to be like in general, and what happens to them over time. And specifically, we're taking a look at a system referred to as L98-59. This is a system that's been observed and studied for many years, and it's approximately 35 light years away from us. So, not too far, not too close. But what makes this system exciting is the fact that it contains several planets. Very likely 5, possibly more. But the planet we're focusing on is the planet D, or basically the third planet from the star. And for a very long time, this planet was a bit of a mystery because its density was very unusual and somewhat different from other exoplanets we've seen so far. And especially because this is actually a relatively large planet. It's approximately 60% more massive than planet Earth, and is also approximately 60% larger in size. But now, thanks to the James Webb Space Telescope observations, along with some advanced computer modeling, scientists believe they can finally explain what this planet is like, with the conclusion being that this is actually something we've never seen before, and something that's super unique. So essentially this is an actual lava planet. And I guess first let's define exactly what we think this is, because in this case the definitions are kind of important. And while obviously in our own solar system we don't have anything like this. We obviously have the moon Io as a kind of a closest comparison, but here the only similarity is that it's geologically active. Io is not a lava planet and instead is actually a volcanic moon that sometimes has lava on the surface. And in comparison, a lava planet is technically a terrestrial world where the surface is mostly, or sometimes entirely, made out of magma oceans. Although exactly what it looks like is obviously unknown to us. Now this example is from NASA, so this is what NASA scientists think it might look like, but in reality we have no idea. And while based on many different studies, there are possibly 3 ways this can happen to a typical planet. First, a planet might be very young and has not cooled down yet. That's basically what happened to Earth back in the days when it just formed, and when it very likely also contained a lot of magma oceans before it finally cooled down. Second, it might have also just survived some kind of a massive collision, such as the one that formed the moon. And surprisingly, this is also something that happened to our planet, implying that Earth actually went through 2 separate stages of being a lava planet. First after its formation, and second time after that massive collision. But the third way is a lot more relevant in this case. It's basically a planet that orbits extremely close to its star, which then results in 2 separate effects. First, the intense radiation melts the crust directly, mostly because obviously the planet gets very hot. But second, there's a lot of tidal heating, usually from its partners, and in this case we know that this planet contains quite a lot. And so here, based on the effects from star's gravity and the gravity effects from the partner planets, this planet ends up being stretched and squeezed so much that the friction inside overheats it and results in the internal material melting completely. In some sense, that's also what happens on the Jupiter's moon Io. It's the only reason it's volcanically active. But for this planet, things are actually kind of unusual because this is what's known as a super-Earth. So once again, it's larger and more massive than Earth, implying much more extreme effects. But when astronomers measured the density of the planet, it seemed to be kind of low for a typical super-Earth. It was only about 2.2 grams per cubic centimeter, which is actually closer to a typical ice giant and not a terrestrial world. For comparison, the density of Earth is 5.5. And so when we see these low-density planets, they're usually assumed to be water worlds, or basically planets covered in deep oceans, very likely containing an extremely dense atmosphere. Or they could also be gas dwarfs, or essentially terrestrial planets containing a huge envelope of gas, most likely made out of hydrogen. But this planet also orbits very close to the star, so none of these explanations made sense. With the orbit of just 7.5 days, here either liquid water or hydrogen envelope would not be able to exist. They would have been stripped by the star a long time ago. And so this planet seems to have something else going on that we've just never seen before. And that's the focus of this very recent study by the researchers from the University of Oxford. Because here they argue that this is not water or gas, instead it seems to be a molten planet with a permanent magma ocean. And this conclusion was reached by using a very specific modeling technique using the framework referred to as Proteus. And so here scientists found that the planet is likely trapped in a state where it can never fully solidify and can never fully become a real terrestrial planet. It's basically in a constant state of being a liquid magma ocean planet, which seems to be caused by a combination of tidal heating along with a very powerful greenhouse effect from its own atmosphere. And here the atmosphere seems to act as a very thick greenhouse blanket. It basically traps all of the heat from the interior and from the star and keeps the mantle in a constant molten state. And surprisingly, based on the calculation and also based on what we know about the star, it seems to have been like this for billions of years. In other words, it potentially has never changed and was potentially always a lava planet. And the evidence for this is pretty strong based on the observations from the James Webb. And that's because in this case, the telescope observed some very unusual and somewhat unexpected emissions involving sulfur dioxide and hydrogen sulfide. And it's unusual because on most planets, we don't expect to see this in such amounts. As a matter of fact, sulfur dioxide should not be seen in these amounts anywhere, and especially in the upper atmosphere. Mostly because it usually very quickly gets recycled back into the planet and does not stay in the atmosphere too long. And so in this case, researchers believe that this planet experiences what's known as photochemistry, which means that the light from the star hits the gases in the atmosphere and then triggers specific chemical reactions, creating sulfur dioxide in real time. And this is a very similar process to what we see on various hot Jupiters, although very often much closer to the parent star. And so apart from hot Jupiters, this has never really been seen on any super-Earth or any terrestrial planet. And since this is now visible on a much smaller planet, it suggests something very specific about the planetary interior. And the scientists in this case believe that because of a very specific balance of oxygen and iron, it basically ends up releasing a lot of sulfur from inside, which then evaporates from the magma ocean. And so unlike Earth, where sulfur is mostly trapped in the core, here it's the magma ocean that seems to act as a reservoir, with all of the sulfur occasionally released as a gas. And it's actually this magma ocean that also plays a very important role in maintaining the planetary atmosphere. It seems to be directly responsible for forming the sulfur-based atmosphere and releasing many of these sulfur gases, because otherwise none of this makes sense. No planet should contain so many sulfur-bearing gases, and all of this should have already been stripped away. And so based on this discovery, researchers suggest that current planetary classifications do not make sense for this particular planet, because this is not a rocky planet, it's not a gas giant, it's not an ice giant, and it's not really a super-Earth. Instead, it represents a kind of a molten, volatile rich class that we've just never really seen before, or have seen but just didn't know what we're looking at. And so at the moment, researchers decided to classify this as volatile rich magma super-Earth. Not the easiest name in the world, but I guess it will have to do for now. With the category sitting right between the traditional rocky terrestrial planets and some kind of a gas dwarf, such as a small Neptune-like planet. And assuming this is correct, it then has a very strange structure. It essentially has a molten core, a molten mantle, but also an extremely large molten ocean on the surface. And on top of this, it also has an extremely thick volatile layer, with the atmosphere containing a lot of sulfur and possibly even water. And because the star is very likely stripping all of this atmosphere at the same time, it may even contain a somewhat large tail containing all of these gases escaping from the planet itself, but the magma ocean is constantly refilling them and releases them back into the atmosphere, with all of this preventing the planet from becoming solidified and becoming a bare rock. And though traditionally astronomers usually try to find planets with liquid water, here the planet L98-59d suggests that the liquid can also be something else. Or essentially it suggests that there is a spectrum of planets resembling steam worlds or sulfur worlds that can actually support complex chemistry and potentially contain their own liquid cycle, but in this case involving entirely different elements. Although obviously here this would be way too hot for life, at least on the surface. Although in this case there's still one mystery. Where exactly did this planet even get these volatiles, and specifically all of these sulfides? Because any planet forming so close to the star should not contain them. And that implies that this planet possibly formed much farther away from the star and eventually migrated to its current close orbit, which means that there was probably a time when it was a very different planet, possibly resembling something else we've seen before, maybe some kind of a super-Earth, or possibly some kind of a very massive terrestrial planet. But as it got closer and closer to the star, and as it became hotter and hotter, it eventually transformed into the super hot planet it is today, with the current temperature being up to about 1900 degrees Celsius, hot enough to melt most rock and most iron alloys. But here this also solves a mystery in regards to exoplanets, and specifically a mystery of what's known as radius valley. And that's because when scientists find exoplanets, there is this very strange gap where a lot of planets about 1.5 times the size of Earth seem to be absent. Or basically, planets of certain size seem to be extremely rare, but the confirmation from this planet suggests that many of these small rocky super-Earths possibly just started as much larger objects and eventually transformed. In other words, over billions of years, some planets might shrink and might end up losing some of their gases to outer space, and thus produce objects of a very different size. But here, since this object is right in the middle of the valley, we essentially caught one planet in the middle of this transition stage. It's essentially a kind of a missing link, showing us how planets can evolve from somewhat puffy gas worlds into much smaller molten worlds, which eventually solidify and become very hot terrestrial planets, many of which have been discovered in the last few years. And so this is not just discovery of a lava planet, it's also a discovery of a very important missing link. But at the same time, this obviously also introduces this new planetary category involving planets with a permanent magma ocean and planets that are permanently molten, something that until now really only existed in science fiction. But here we can now see that even molten planets can still produce very massive atmospheres, and sometimes these atmospheres are actually very strange, and even contain things like sulfur that we generally do not see. But at least for now, that's all we know. We'll definitely come back and discuss these strange planets in some of the other videos. Until then, check out some of the previous videos on lava planets in some of the links in the description. Thank you for watching, subscribe, come back tomorrow to learn something else. Support this channel on Patreon, where you can find additional videos without any ads, and can DM me directly, or by joining a channel membership that grants you early access. You can also support this channel by buying the Wonderful Person t-shirt in the description below. Stay wonderful, I'll see you tomorrow, and as always, bye bye.